Alright, you rock stars, here we go, section 3.31, analyzing graphs of quadratic functions, day number 1. We're going to split this up into 2 days. We're going to take it a little slow just to make sure that we get every little bit that we need. Graphing functions of the type f of x equals a parentheses x minus h squared plus k. So these functions here are going to be all parabolas if it's this type. Parabola, parabola. And if we see this here, we actually might be able to expect it because a, h, and k are all just going to be numbers. And if you remember from our chapter 2 transformations, this is basically just a parabola. The parent function is a parabola. And the child here has been transformed 3 different ways. It's got a horizontal translation of h here, noting that it's x minus h. It's got a vertical translation of k, plus k out here. And then it's got a vertical dilation up front. So those are the 3 different ways that any of these functions are going to be transformed. And really the question is, can you identify a, h, and k, and then can you figure out exactly what they do to the vertex, or what they do to the line of symmetry? What do they do to whether or not it opens up or down? Check this out. We've got a whole... this is basically a summary of everything we're going to talk about, but I'm just going to start off with some examples here. Let's say you're given f of x is equal to 3x, 3 parentheses, x minus a quarter squared minus 2. Now, from our work in transformations, we can pull apart that the a value is going to be 3. Now, when we did transformations, we had a, b, c, and d, and they were different from this. But when we're working with parabolas, it's basically an a, an h, and a k. A is here, h is here, and k is here. So we've got a is equal to 3, h is equal to positive 1/4, because remember the formula asks for x minus h. H is positive 1/4, k is negative 2. So where's the vertex going to be? I'll tell you where the vertex is going to be. It's going to be at 1/4 comma negative 2. And that's because for the parent function, just x squared, a normal parabola, the parent parabola is going to have a vertex at 0, 0. But then if it gets shifted horizontally 1/4, and the vertex shifts over, and then it shifts down 2, negative 2. That's why the vertex is there. So I take the h value and the k value and I turn it into the new vertex. A parent parabola, it just normally opens up, and so therefore if you vertically dilate it by a factor of 3 here, it's still going to open up. It might be narrower, it might be stretched upward, but that still means that it's open up. There's going to be a line of symmetry. Parent parabola is going to have a line of symmetry along the y-axis, and here the line of symmetry just gets shifted over to where the vertex is at 1/4. So that's the h value here. And then the vertex itself is going to be not a maximum, but a minimum, because we know that the parabola opens up, and then this should be a positive. This is plus 1/4. Plus 1/4. Plus 1/4, comma, negative 2. That's where the minimum is. So we're going to take a break right now, and I'm going to actually verify that using Desmos. Let's do the same thing again here with example 2. Identifying the a, h, and k values, we've got out front, we've got an a value of negative 3. Inside, we've got an h value of, careful, negative 5, because it's the formula expects x minus 5, x minus h. So if we really needed to, we could rewrite this as x minus negative 5. So therefore h equals negative 5 and k equals positive 7. That means we've got a vertex at negative 5 comma 7. it opens down. Look at that. The a value is negative 3. So because it's negative, it opens downward, like an N, not a U. The line of symmetry got shifted over to negative 5. And the maximum, well, it's not going to be a minimum anymore. It's a maximum. The top of the N, the top of the downward-facing parabola is going to be negative 5, 7. Let's jump to Desmos to verify. One last example. A is 1/2, H is negative 1. Remember, because we're expecting x minus h, we have to convert that to a negative 1. And then k is equal to negative 1. I want you to find the vertex, but I'll let you know that the parabola is upward facing because a is equal to 1/2, and that's greater than 0. It's a positive number. The line of symmetry is x equals negative 1. It is a minimum at negative 1, negative 1. All right, kiddies, it's play at home time with Desmos. What that means is when I do something on Desmos, you do it too. Make sure you can show me your saved Desmos graphs when you arrive in class tomorrow. So the purpose of graphing it and understanding the algebra is that you've got two different ways of confirming the same answer. And sometimes you'll be able to graph very easily, and sometimes you'll be able to look at the algebra, the equation, very easily. But in any case, we have to make sure we understand both and perform both so that they can mutually confirm each other and we can understand what's going on. Plus, sometimes we're just not going to have a graphing calculator, or sometimes we're not going to have access to Desmos, or sometimes we're not going to have access to the equation. So what we have to do is you have to be able to understand both, and they should be able to mutually confirm each other. All right, so example 1 is f of x is equal to 3. I'm just going to type in a 3, parentheses x minus 1/4, and k is equal to negative 2, minus 2. There it is. This is our parabola. This is what it looks like. And we can see that we do have a minimum at positive 1/4, negative 2. Example 2, we've got an a value of negative 3, an h value of negative 5, and a k value of positive 7. And so here we can see we've got a vertex at negative 5, 7. There it is. It is a maximum, and the line of symmetry here is x equals negative 5. I will let you do example number 3. But this is going to be called 3.31 Analyzing Quadratic Functions, Day 1. That might be a good time to tell you that the capital of Idaho is Boise. Boise, Idaho. Never been there. If you've been there, tell me about it in class tomorrow. And begin assignment 3C1. Copy the problem list and do the first problem. I'll see you in class.